Hello friends, myself R.D. Mahajan presenting my video on inverse Laplace transform technique partial fraction method. Second case, when factors are real and repeated. And in this video, I am going to discuss three simple examples. Example number first, find inverse Laplace of 1 upon s minus 2 into s plus 2 whole square. Here the second factor is a repeated factor. Therefore, how to obtain its inverse Laplace transform, I will explain. Before to start, please watch the video up to end so that all the examples are clear to all of you. Whenever the factors are real and repeated, a way to write down partial fraction method is that 1 upon s minus 2 s plus 2 whole square is equals to, for this non-repeated factor, it is a upon first factor, that is s minus 2. For this repeated factor, a way to write is b upon that factor, it is s plus 2. And as it is repeated, next is c upon, if increase the power by 1, therefore it is s plus 2 whole square. If it is repeated third time, it is next d upon s plus 2 whole cube, like this. We can rewrite. We can write. Therefore, we call this equation number 1. And then finding the LCM of these three terms, LCM is s minus 2 into s plus 2 whole square. And therefore, 1 is equal to, remaining term is s plus 2 whole square. A into that s plus 2 whole square. Divide by this, remaining term is s plus 2 into s minus 2. And dividing by this get cancelled, remaining is s minus 2, therefore c into s minus 2. And then collecting, before that, expanding this bracket by a plus b whole square. A square means s square, plus 2ab means 2s, plus b square means 4, plus b into a product of these two terms. It is s square minus 2s plus 2s get cancelled, and or as the factors in the form of a plus b and a minus b, that product is a square minus b square, and plus c into s minus 2. Then collecting the terms of s square, s and constant term. Therefore, here it is a square and b square. Therefore, taking s square common from these two, we get a plus b into s square. Then collecting the terms of s, here it is 2a, no term of s, and plus cs. And then constant terms are 4a minus 4b and minus 2c, and that is equals to 1. And then comparing two sides, therefore here the coefficient of s square is a plus b, and no term of s square, therefore its coefficient is 0. It implies we get the value of a as minus b. Then second, therefore when we square it, it becomes s square twice ab means 2 to the 4s, and plus b square means 4. And therefore, when we collect the terms of s, we have remaining terms as 4a, and here it is c. And then constant terms are 4a minus 4b and minus 2c. Therefore, 4a plus c is equals to 0. It implies, replace a by minus b, we get minus 4b plus c equals to 0 means c is equals to 4b. Okay, and therefore lastly the constant terms are 4a minus 4b minus 2c is equals to, here the constant term on left hand side is 1, therefore it is 1, that is substituting the value of a as minus b, therefore this become minus 4b and minus 2c is equals to 1, therefore this one is minus 8b is equal to, or minus 2c minus 2 times c, the value of c is here 4b and therefore it is 4b and that is equals to 1. We get minus 8b as minus 16b is equals to 1 and therefore we get the value of b as minus 1 by 16. As minus 1 by 16 and therefore substituting that value here in this, we get the value of a minus of minus 1 by 16, that is nothing but 1 by 16, and c is equals to 4 times b, value of b is minus 1 by 16, 4 by 16 we get minus 1 by 4 and therefore whatever the values of a, b, c, we put it in equation 1 and then we determine the inverse Laplace transform. Substituting the values, we get a as 1 by 16 divided by s minus 2 minus 1 by 16 divided by s plus 2 and c as minus 1 by 4 divided by s plus 2 whole square. Then taking inverse on both sides, inverse of left hand side and inverse of left hand side and inverse of right hand side, and then taking individual inverse of right hand side term, 1 by 16 outside, inverse Laplace of 1 upon s minus 2 minus 1 by 16 inverse Laplace of 1 by s plus 2 and minus 1 by 4 inverse Laplace of 1 upon s plus 2 whole square. Then applying standard result, it is 1 by 16, inverse of 1 upon s minus a is e raised to at, a is here 2, therefore e raised to 2t minus 1 by 16, inverse of 1 upon s plus 2 is e raised to minus 2t, s replaced by s plus 2, therefore applying shifting theorem, as it is replaced by s plus 2, we have to multiply that term of 1 by s square, inverse of it, as e raised to minus 2t into inverse Laplace of 1 upon s square. Neglecting that 2, the remaining term is 1 by s square. This is as per the shifting theorem. And then rewriting it, it is 1 by 16 e raised to 2t minus 1 by 16 e raised to minus 2t minus 1 by 4 e raised to minus 2t, and inverse of 1 by s raised to n, whenever it is positive integer, it is t raised to n minus 1, 2 minus 1 we get 1, divided by 1 factorial, nothing but 1, and therefore this is the required answer. And inverse of left hand side is f of t, therefore f of t is equals to, or nothing but inverse Laplace of this given function or term is 1 by 16 e raised to 2t minus 1 by 16 e raised to minus 2t minus 1 by 4 e raised to minus 2t into t. Second example, find inverse Laplace of 1 upon s into s plus 1 whole cube. Here it is a product of two terms. The first one is non-repeated, and s plus 1, its cube means it is repeated 3 times, and therefore using this technique we get that 1 upon s into s plus 1 whole cube is equals to, here it is proper fraction. Proper fraction means degree of numerator term is here 0 and degree of denominator term is 4. 0 less than 4 means it is proper fraction, and as it is proper fraction we can apply partial fraction technique. Therefore for this, first it is a upon s, the second term is a repeated term, therefore b upon s plus 1 first time, repeated second time, therefore it is c upon s plus 1 whole square, and again repeated, therefore d upon s plus 1 cube. Equation number 1. Then finding the LCM of this 4 term, LCM is s into s plus 1 whole cube. Dividing by s, s's get cancelled, therefore we get 1 is equals to a into remaining term. Remaining terms here s plus 1 whole cube plus b into, dividing by s plus 1, s plus 1 whole square remains, therefore it is s into s plus 1 whole square plus c s, dividing by this remaining term is s plus 1 whole s plus 1 only into this s, then dividing by this term get cancelled, remaining is s only, therefore it is d into s. Then simplifying this, it is a into, expanding by a plus b whole cube, a cube 3a square b means 3s square, 3ab square 3s, and plus b cube, 1 cube is 1. That is the expansion of this term s plus 1 whole cube. Then b into s multiplied by, expanding this s plus 1 whole square, expansion is s square plus 2s plus 1 plus c into, multiplying it inside we get that term as s square and s and plus ds. Then collecting the terms of s cube, s square, s and constant term we get, here it is a into s cube, b into s cube, and no term of s cube, therefore a plus b into s cube. Then collecting the terms of s square, 1, 2 and 3, therefore it is 3a plus 2b and plus c into s square. Then constant collecting the terms of s, therefore 3as then bs and cs, therefore 3 terms of s. And then constant terms are a, no constant term, then no constant term, and here one more term of d, s, therefore plus d, and only a. Then comparing left hand side with right hand side, no term of s cube, therefore we get a plus b is equals to 0. It implies b is equals to minus a. Okay, then coefficient of s square, it is 3a plus 2b plus c, and no term of s square on left hand side, therefore it is equals to 0, but b is minus a, therefore 3a minus 2b, the value of b is minus a, therefore that becomes minus 2a plus c is equals to 0, means 3a minus 2a, it is a plus c is equals to 0 in simplified form. Next one, coefficient of s, 3a plus b plus c plus d, and that is equals to no term of s, therefore again 0, 3a plus b, the value of b is minus a, therefore minus a plus c and plus d is equals to 0. We have 3a minus a as 2a plus c plus d is equals to 0. And then lastly, here the constant term is a, and the constant term on left hand side is 1, therefore we get a is equals to 1. Then substituting that value of a as 1, we get the value of b, therefore b is equals to minus 1. Then a plus c is equals to 0, means c is equals to minus a, and a is 1, therefore we get the value of c as minus 1. And then substituting that two values here to get the value of d, finally we get the value of d as 2a. If we transfer, it becomes minus 2a, therefore it is minus 2, minus c, minus of minus, it becomes plus 1, and therefore minus 2 plus 1, we get that value of d as minus 1. Therefore, if we put that values here in this equation 1, value of a as 1, therefore we replace that a by 1, b as minus 1, we get that value of b as minus 1, c as also minus 1, and d as minus 1. Once again I will repeat this step. A is 1, therefore 1 by s, b is minus 1, therefore minus 1 upon s plus 1, c is minus 1, minus 1 upon s plus 1 whole square, and d is minus 1, therefore minus 1 upon s plus 1 whole cube. Next step is inverse on both sides, and therefore inverse Laplace of left hand side 1 upon s into s plus 1 whole cube, inverse of right hand side, and then taking individual inverse, therefore it is inverse of the first term 1 by s minus inverse Laplace of 1 upon s plus 1 minus inverse Laplace of 1 upon s plus 1 whole square, and lastly minus inverse Laplace of 1 upon s plus 1 whole cube, and then applying standard result. Inverse of 1 by s is 1, inverse of 1 upon s plus a is e raised to minus 8t, and inverse of 1 upon s plus a raised to n. By shifting theorem, it is e raised to minus 8t, and inverse of 1 by s raised to n is t raised to n minus 1 divided by n minus 1 factorial if it is positive integer. And therefore, applying all this result, we get inverse of left hand side is f of t, suppose. Inverse of 1 by s is 1 minus inverse of 1 upon s plus 1 is e raised to minus 80. A is here 1, therefore it is e raised to minus t. Next, applying this result, it is minus e raised to minus 80. A is once again 1, therefore e raised to minus t into inverse of 1 by s square. It is t raised to 2 minus 1 means t divided by 1 factorial. 1 factorial is 1. Next, minus, again shifting theorem, it is e raised to minus 80 as s replaced by s plus 1, and therefore e raised to minus t into inverse of 1 by s cube is t raised to 3 minus 1, we get 2 divided by same factorial, that is 2 factorial, and therefore simplifying it, we get 1. From all these three terms, I can take minus e raised to minus t common. Here it is 1. Next one is plus t. And here it is t square by 2 factorial is 2. This is the required answer. Or required inverse Laplace. Last example, example number 3. Find inverse Laplace of 2s plus 3 whole divided by s plus 2 first factor into s minus 1 whole square. If you try to find the degree of numerator term, it is 1, and degree of denominator term 2 and this 1 means 2 plus 1, that is 3. Therefore 1 less than 3 means it is proper fraction, and as it is proper fraction, by partial fraction technique, second factor is a repeated factor. Therefore that 2s plus 3 whole divided by s plus 2 into s minus 1 whole square is equals to f1 first factor, as it is a distinct factor, and for this repeated factor, next one is b upon that factor s minus 1, and as it is repeated once again, therefore c divided by, we have to increase power by 1, therefore we get s minus 1 whole square. We call this as equation 1. And then finding LCM of this three term, LCM is s plus 2 into s minus 1 whole square. Dividing by s plus 2, we get therefore 2s plus 3 is equals to a into s plus 2 get cancelled, remaining is s minus 1 whole square. Therefore a into s minus 1 whole square. Dividing by s minus 1, 1 s minus 1 get cancelled, we get b into s plus 2 into s minus 1. Dividing by this get cancelled, therefore c into s plus 2, and then simplifying it, expanding the first bracket, its expansion is s square minus 2s and plus 1, a square minus 2ab plus b square, then b into s square minus s plus 2s, addition is plus s, and 2 into minus 1 we get minus 2, and c into s plus 2. Then collecting the terms of s square, s and constant term. one term of s square, second term of s square. Therefore, it is a plus b into s square. Then, collecting the terms of s, 1, 2, 3. Therefore, minus 2a plus b and plus c into s. Then constant terms are a minus 2b and plus 2c, and that is equal to 2s plus 3. Comparing two sides, as equality sign is there, the coefficient of s square is here, a plus b, and no term of s square, therefore its coefficient is 0. It implies b is equal to minus a. Then minus 2a plus b plus c is equals to, coefficient of s is here 2, therefore equal to 2. Then substituting the value of a as b as minus a, therefore this one becomes minus 2a, again minus a, and plus c is equals to 2 minus 3a minus 3a plus c equals to 2. And then lastly, a minus 2b plus 2c is equals to constant term on the left hand side, it is 3. Put the value of b as minus a, therefore a minus and that minus will become plus 2a plus 2c is equals to 3. We get that term as 3a plus 2c is equal to 3. Opposite sign terms, therefore adding these two equations, plus 3a minus 3a get cancelled, 2c plus c we get 3c, 2 plus 3 we get 5, and therefore c as 5 by 3. Substituting that value of b, we get in this equation, any one of this equation, we get minus 3a plus c, c is 5 by 3, and that is equals to 2. Therefore 3a is equals to, transferring to right and this to left, we get 5 by 3 minus 2. 3 to the 6, 5 minus 6 we get minus 1 by 3, and therefore a is equals to, dividing by 3 we get that value as minus 1 by 9, and a as minus 1 by 9, put here we get the value of b as minus of this, therefore we get that value as 1 by 9. Therefore a is minus 1 by 9, substitute here, b is 1 by 9, and c as 5 by 3. And then after substitution, we require to find inverse on both sides. taking inverse on both sides, inverse of left hand side and inverse of right hand side, we get inverse of left hand side is 2s plus 3 whole divided by s plus 2 and s minus 1 whole square, and inverse of right hand side, individual inverse, we get minus 1 by 9 outside, inverse Laplace of that term 1 upon s plus 2, then plus 1 by 9 constant term outside, inverse Laplace of 1 upon s minus 1, then plus 5 by 3, inverse Laplace of 1 upon s minus 1 whole square, and then using standard results. Therefore, it is minus 1 by 9. Inverse of 1 upon s plus a is e raised to minus at. Therefore, e raised to minus 2t here. For s minus a, it is s e raised to at. Therefore, it is e raised to a is 1. Therefore, 1 times t means e raised to t, and 5 by 3. Here s is replaced by s minus 1. Then applying shifting theorem, it is e raised to minus at means e raised to plus at, e raised to t here, into inverse Laplace of the remaining term. Remaining term is here 1 by s square. Neglecting this 1. Remaining term is 1 by s square. And then again simplifying it, minus 1 by 9 e raised to minus 2t plus 1 by 9 e raised to t, 5 by 3 e raised to t, and inverse of 1 by s raised to n is t raised to n minus 1. 2 minus 1 is 1, and divided by 1 factorial. 1 factorial is 1, and therefore inverse of left hand side is f of t. This is the required inverse Laplace transform. Therefore, in this video, I have discussed 3 simple examples for this case number 2, when factors are real and repeated. In my next video, I will discuss third case, when factors are in quadratic form, real and quadratic form. How to obtain that inverse, I will explain in that video. Therefore, if you like my video, please share it, as well as subscribe to my channel. If you are not subscribed yet, please subscribe it, and to receive the notification of all my such type of new videos, press the bell icon. Thank you. Thanks for watching.